All right, so this is 3.5. In 3.5, we're going to use what's called a general transformation rule. I went over every one of these transformations with you in Algebra 2 except for one of them. And as we do examples, you'll start seeing what they mean, but you got lots of boxes to write in. So we're using a transformation code rule called A times F of B of X minus H plus K. Are H and K familiar to you? How about the A up front? Yes, no? You've used it before. I promise you have. Anyways, these little blocks here. A is what we call a vertical stretch. It multiplies Y values because it's stretching things vertically. If it's negative, you reflect on the x-axis. Some gum. We'll say B for last because B is new to y'all. That's the concept of B is. Anybody know what that H does in the middle? Actually, maybe if you looked at an equation, you'd know what it does in the middle. X plus 3 squared. What's that plus 3 do? What's it do? It does something to X. Well, I guess you guys forgot. Yeah, it tells you how you're supposed to move something. It's a horizontal shift. You move the mother back 3 in that example. About that minus 5, what's that do to the graph of mom? Moves it down. Call that a vertical shift. Hopefully I put the F in here. There we go, vertical shift. Trust the sign. So we talked to this. You guys should be, although you seem to have forgotten every bit of it, should be comfortable with vertical stretches, horizontal and vertical shifts. B is new to you. B handles what we call a horizontal stretch. Horizontal stretch is 1 over the absolute value of whatever B is. And I actually left something off there. Multiply X values by 1 over the absolute value of B. Sometimes it stretches, sometimes it compresses. Then we just call it a horizontal stretch. "17 minutes to go. Anybody need more time? Still see some pencils. Y'all all worried about your pretty handwriting. Only person that's got to read it's you, isn't it? You and Jesus. Pretty sure he can read it. Anyways, I'm going to do our first example here. We graph the function f of x equals x plus 3 squared minus 5. Now, whenever you do a transformation or you graph a function, you're supposed to think about mom. Mom What function? X plus 3 squared. What's mom? This is x plus 3 squared. What's mom? Mom is y equals x squared. Mom has 3 key points. What are they?
Negative 1, 1, 0, 0, 1.
Negative 1, 1, 0, 0, and 1, 1. These are key points. I'm going to show you how to do this 2 ways. First way is probably going to be the most confusing, okay? The first way is to manipulate points. But it also shows that you truly understand what's happening on. Now, this x plus 3, this piece right here, it's telling us to subtract 3 from x. What it means? Minus 5 means subtract what from 1? Subtract 5 from 1. Because of the types of shifts that they were. X plus 3 is part of the horizontal shifting, and the minus 5 is vertical shift. So one thing we do is we use points. So the child has the key points. We're supposed to take away from each of those x values? 3. You take away 3 from negative 1, you're at negative 4, negative 3, 2. Now what are you supposed to take away from each of your y values? 5, right? No. I'm just looking at these things. 1 minus 5 is negative 4. 0 minus 5 is negative 5. 1 minus 5 is negative 4 again. Using the points is probably the way of best understanding, and it shows that you understand it in depth, but it's not the easiest way to do it, especially when you do lots and lots of transformations. Anyways, what I gotta go to? Negative 4, negative 5. Negative 3, negative 5. Why is that a negative 5? Yeah, it's a negative 4. What was that? Negative 4, negative 4. All right, there. I got negative 3, negative 5. Which is the vertex, and negative 2, negative 5. There's your child. And points is probably the harder way of doing it. It really is. Usually when you do problems like this, the accepted method is to graph the mother function and just show that transformation by moving things around. So this is generally speaking how you want to do it. Graph mom and move her. All you do. There's mom. Call the child f prime of x. I'm going to label it when I do it. I can tell which graph's which just by looking at it. Now, plus 3. How's that shift? Left 3. What I've always done, and it makes it easiest on me, is I've shown that shifting left of 3 by shifting the y-axis 3. Down 5. What's that do to mom? Drops your what? 5. That drops the x-axis 5. For the child, that's the origin. For the child, that is the origin, okay? That's where it ends up. And from there, you just use your key points, but with respect to that as being the origin. So mom had a key point here of 1, 1. That means from here I go right 1 and up 1. Mom had a point at 0, 0. Well, the child just stays there in its origin. Mom had a key point to the right 1, left 1, so I go right 1, left 1. There's the child. Call it F prime of X. By the way, you can do the same thing. I don't expect any of y'all to actually manipulate the points. I would just shift the graph around. Graph mom and move her. Your homework talks about that. You're supposed to always graph mom. Always graph mom. Did you do this last year in Algebra 2? You did. I was there. All right, use the graph fx equals the absolute value of x to obtain the graph of g of x equals twice the absolute value of x. Now, that is the a term in the general transformation rule. What's it say it does to the y values? Y'all just screw with me every day, don't you? Y'all do. It's just want to fuck with my head here. What does it say you do to the y values? Multiply. All right, it's not that hard. No shifting going on, just says multiply the y values. What were the key points for mom, absolute value of x? 0, 0, negative 1, 1, 1, 1. I'm actually going to plot those points here. That's f of x, mom. What are we supposed to do with those y values because that 2 out there? Times it by 2. So this point on mom, 1, 1, what's it become? It must be 1, 2. How about this point negative 1, 1? What's it become? Negative 1, 2. Can you change 0, 0 if you double the y value? No. There's the child. Slope is just twice that of the mom. That's all you do, kids. Any questions so far? Not that I'd be able to hear you anyways. Boring. Worth talking about. It is worth talking about. By the way, that is actually truly called a vertical stretch. It pulled the graph up. This one's actually called a compression. I can do it real quickly. Boring, but still a compression. I just call them long stretches. Anyways, mom is what? 0, 0, 1, 1. You see me use my hand like I was getting rich stuff? There's mom. What happens to mom's y values because of position and a half? They get what? Cut in half. Okay. So this would actually be one half. This guy would be 1/1/2. 0, 0. That's called a compression. Because what happened to mom? Grabbed her and you shoved her down. That's called a compression. The stretches grab her and they pull her up. Huh? We were supposed to do this on the same screen, or just graph each of the following functions, so that's probably a calculator problem. So we'll do it. I'm going to do it piece by piece. I'll add to it. First up is a square root function. You guys remember what that looks like without actually graphing it? It's the arm. Yeah, it's the arm. Like I said, I'm just doing this piece by piece, mainly for the kids that are out. Of course, I don't think anybody's watching anything. I think I've had 52 views so far for the year. Yeah, it's kind of pointless me putting that all in the classroom there. All right, that 2. What do you think it's going to do to it? Look at its location. It's not in front of the function. It's not in front of the root. It's inside the root. If you go back to your general transformation rule on page 1, that's something inside the function, isn't it? It's inside that root. That's the root of twice x. That's inside the function. That's either going to be a horizontal stretch or compression. Now, it says the horizontal stretch is 1/b. So we're going to multiply the x values by 1/b when we do this. So what we're going to do is we're going to multiply our x values by 1/2. What do you think that's going to do to the graph? No idea, huh? All right. Be the second thing I graph. The root of 2x. You might need parentheses. 2 or more you should generally wrap. I don't know what calculator you're using. It actually ended up being the same thing as a vertical compression. That's why I don't usually teach them in Algebra 2. Stretches and compressions really aren't. The horizontal compression is the same thing as vertical stretch. But it took every x value, cut it in half, and at the same time it multiplied every y value by the root of 2. That's what it did. Let's see here. Third one is 1/2 x. What do you guys think? Is that thing going to make it steeper, or it's going to make it kind of shorter maybe? Okay, let's see. Should. Everything's said and done. Of course, the calculator robs you the ability to see what's really going on until you actually do points. That actually did kind of decrease, I guess we'll call it its slope a little bit. There's a reason for that. So there's where you play along the calculator. And I forgot to save that for everybody at home. So I wasn't paying any attention. We're out of time, aren't we? Good for y'all. That means you have no homework, which means you can go home and draw. Don't know how to draw? So I dropped the equation requirement to 25, remember? You don't have to have an equation for everything you draw. Not yet. But again, you do the bare minimum and get the minimum grade. There can be other stuff on it. Yeah. It's like the first one. I just wanted y'all to start over.